Hi everyone, this is Miss Englert for your lesson today, March 8th, 2021. How do we describe different types of planets? So the first thing you're going to do is write 2 observations about this chart. You can find this chart on page 15 of your Earth Science reference table. So you're going to go ahead and type in 2 observations that you can make regarding this chart that says solar system data. On slide 2, we have some notes going over this chart. So the mean distance from the sun, so if you look at the part of the chart that is highlighted, that is the mean distance from the sun. This is the average. So this is the average distance between the sun and the celestial object. Hang on, I can't spell. So any of the celestial objects are here. So we have the sun. Notice that there is no distance to the sun from the sun because it's the same thing. And then the Earth's moon actually tells you how far away it is from the Earth rather than from the sun. Our next slide is the period of revolution. This is the time it takes for the object to revolve, or you can also say orbit, or go around the sun. So notice as we go down the chart away from the sun, and if we ignore the moon, that the period of revolution increases as you go down. Slide 3, the period of rotation. This is actually slide 4. This again is the time, or how long. So this is how long it takes for the object to rotate. Rotate, or we can say, or spin, or okay, the go shouldn't be in there, or spin around in a full circle. So if you start facing one part of the room and time how long it takes for you to spin around and face that exact same point in the room again, that is a rotation. And this one, there's not a lot of rhyme or reason to it. You can actually see that different celestial objects have different periods of rotation. So the sun actually takes 27 days to rotate on its axis. Mercury takes 59. Venus takes 243 days to rotate on its axis. And then Earth, as we know, takes about 23 hours, 56 minutes, and 4 seconds. So not that full 24 hours. And then Mars is kind of similar. And then something that's super, super cool is that Jupiter is way larger than the Earth, but actually rotates on its axis under 10 hours. So it takes less than half the time it takes for us to rotate to have a full day on Jupiter. And also that period of rotation is the day, technically. So eccentricity of orbit. This is going to be how oval shaped the orbit is. If we remember going over eccentricity last week, that's how oval shaped the orbit is. So notice that all of these numbers are between 0 and 0.206. Well, that just means that they are between 0 and 1. The closer they are to 1, that's a terrible one. The closer they are to 1, so if you're closer to 1, it is more eccentric. Also known as more oval shaped for our planets. So you can go through there and see who is the most eccentric out of all of the planets. And then who is the least. Next is equatorial diameter. And this is just, you guys should know what diameter is from your other classes, and that is basically how wide it is at the equator. So as you would imagine, the larger the planet, the greater the diameter of that planet or celestial object. Next is mass, and this mass column, as you can see, is compared to Earth. So the masses on here is how many times more massive it is than the Earth. So the Sun is 333,000 times more massive than Earth. Earth is 1 times as massive as Earth. That means that Earth is the same mass as Earth. And then you can see Jupiter is 317 times more mass than Earth. And remember, mass is really just how much, stuff is in an object. That stuff is, of course, atoms and other building blocks of matter. But to keep it simple, we're going to say stuff. Our next slide is density. So remember, for density, we went over this last semester. Density is how much mass. So that's going to be how much mass there is. So we looked at mass on the other side, and that's multiplied by, or rather, that's compared to the size of Earth. That's going to be how much mass there is for the volume of the planet. And then you need to remember, if density is less than 1, the object will float in water. So there is one of our planets, I want you to highlight it, which one of our planets is actually less dense than water. So our last couple of slides here, talking about our different types of planets. So our terrestrial planets are our rocky planets. So those are all the planets that are closest to the sun. So we have Mercury, we have Venus, Earth, and Mars. And then the moon is not a planet, but the moon is also, I guess we can call it a rocky moon or a terrestrial moon. So these planets, if we look at our chart, these planets are these first 4. Mercury, Venus, Earth, and Mars. Those planets are small. They are low density. Oh, hang on, they're not low density at all. I'm sorry, they are small. They are high density. They are close to the sun, which means that they are a closer distance. And then they have a short period of revolution, which means it doesn't take them as long to orbit around the sun. On the other type of planets, we have our Jovian planets. So Jovian planets are our gas planets, which means that they are primarily made out of gas. Some of them have a solid core, but the majority is gas. So these planets are very large, and because they're made out of gas and they are large, that means that they have a low density, they are farther from the sun, and they have a long period of revolution. And so during class, we are actually going to do a project, and that project is going to be as a Google quiz, starting with our planet dating profile project. So space is infinite, and so is loneliness. Sad face. Luckily, we are here to help you find your solar mate. So the following celestial bodies that you will see on the Google Classroom want to host a solar system party and are looking for a date to help them plan it. So you're going to look at these dating profiles on that Google quiz, and you're going to decide who do you think should go to the party together. You're going to complete the chart on that quiz using the information from page 15 of your Earth Science reference table. And that is all. Thank you guys for tuning in. Bye.